Hey, this is Dark Guardsman, and we're back with part 3 of Let's Make a Snow Machine. So one thing I did forget to do in the last part is I did forget to register the tile IDs, which is kind of convenient because when you're working with blocks, you don't normally need to register a tile ID unless you have one. Of course, we have one, so we need to register one, and as well, we're going to do the logic this episode, so it kind of fits together. To register your thing, we're going to go ahead and pop Dice Boom Classic, because I forgot the actual line of code to do this. Yeah, it's game registry. I was actually about to call like Forge registry or something. So game registry, and then you want the class file, and then the registry key. Now we're going to use a prefix. I have discovered though that with the actual tile registry, it does not prefix your mod in front of it. So you need to make sure your names are unique. The easiest way to do that is to prefix your mod in front of it. So we're going to do our class file. So our class file is going to be tile snow generator, or tile snow generator.class. Now this wasn't going to cause any major problems. Eventually we would have crashed if we tried to do anything with a tile, and it would have broken because we weren't mapped. But for the most part, it works. So we're going to do this. We're going to do prefix plus, and then we're just going to call it snow generator because there's no reason to use any unique names. Actually, even on this note, what we can literally do is just go block snow generator dot get registry name, and it's the same thing. It'll work just fine because it'll actually put our names here. And then what else are we missing here? So it actually wants, and of course with that we need to actually do two strings. So if you do the registry name, you actually have to two string it because registry name is a resource location, and it actually is comprised of two separate parts, which would be your mod and your actual name of your block. So you can get those separately, and use two string, and the two string method will of course just give you the resource domain and colon that. It works just fine. So yeah, that'll register our tile entity. Now to get into the actual logic, we're going to go actually to our tile class, because it's the only other class we need to really work with at this point. We've already finished up all the registry calls, we've already finished up the textures and got them loading, so we got a unique item to look at. So now the only thing that's left to do is actually do the tile logic. So let's go ahead and close a few of these down, and we get this open. So update method is the only thing we got to work with. And to start with, we're going to do the most basic thing ever. We're going to make a tick system. So we're going to make sure we can track how many ticks we've existed. So int ticks equals 0. Now you can use a long or an int for this. I'm going to use an int because we really don't need large numbers for this. To be honest, you can get away with a short, because if you need more than like 32,000 index reference, you're doing something wrong. Or you probably should be using some other counter. So with this, we want to do pretty simple. We're going to go ticks -1 is greater than or equal to integer.max value. You want to make sure you track this, because if somebody leaves their world server up long enough, you could actually crash their game. Now integer actually goes to like a ridiculously large number. It's somewhere like in the range of like 2 billion or something like that. I don't know the exact number. I really should probably memorize it. I just know it's big. And then what we do is you just reset ticks back to either 0 or 1. We're going to do 0 because you no longer need to actually keep track of your first tick. If you want to do first tick stuff, you do use the method onload, which I'm going to go ahead and copy and put in here, but I don't think we need it. In case you ever do, I just want to go put this. This will be called as soon as your tile is placed in the world. So if you actually want to do any logic, say register your tile or do something or do some checks or something like that, onload is a very good idea because it'll be called before the first update method is called. So it's a really good usage for that. After this, we want to do some basic ticks. We don't need packet data, so we're good there. So we don't have anything to send to the client. So the only thing we really need to do is do a tick for power output. For power output, we're just going to keep it simple. We're going to just use the built-in energy class. I believe it's called energy buffer. No, it's called energy storage. So this will be our power storage. So we'll have that really quick, and we set energy, capacity, max receive, max extract. You could tell this is based off of thermal expansion. I don't normally use something this complicated, and to be honest, I'm really tempted just to not use this. But what we're going to do is we're going to set the can receive to 0. So we're going to register this, and we're going to set everything up. This is actually a good use for our onload method. So power equals new energy storage. You could of course have done this in your constructor, but I do not recommend doing a lot of stuff in your constructor unless you really need to. So say for example you wanted to come through later and maybe make a quick tile class to do some testing, you may not want to actually have loaded your energy storage and everything else in here. So onload is a really good opportunity to use this. So this actually is going to require 4 integers. We could just use a capacity one, which will then just set everything to our capacity. But we're actually going to do some control on this. So to be honest, with this being thermal expansion design, I'm actually happy with this because this will give us an opportunity to toy around with the max receive to balance out this tile. So one thing I didn't discuss in the design thing is we do want to balance this. We want to make a tile that can be placed into a normal existing world, and actually reasonably use with all the machines and not produce an exorbitant amount of energy. For this though, the balancing numbers, we also want to make sure they're configurable. So what we're going to do is actually set up some configs. So public static, I believe there's an annotation we can use for configs. I'm actually not going to bother with the annotation. I'm going to do it the old school way here in a second. But we can do public static int, and we can set up, say, power capacity, and we're just going to call it power cap. And I want to say this can store 1,000 forge energy. So we're going to use the forge energy system for this, which is actually, in order to implement that, we're actually going to have to implement capabilities. There actually is a method here, so it does actually use a capability deserializing. So there should be a has capability. Let's actually look for the has capability method first, because that'll get us our get capability. So we want to copy these two methods, and we want to put them in our class file here. We want to make sure we call super on it, because if you don't call super, you're not going to get anybody who's going to attach a capability to your system. So has capability, and then you want to pass in capability, and then facing, and of course we can fix this right here. So this is actually implemented here, so that Forge has an easier time of actually applying these to the entity class, but you don't have to actually do the full thing that way, because you can do imports, of course, in your class files. Forge just ignore the import system because it's just easier to work with it if you don't have to import everything. When you're getting into code, by the way, when your code actually compiles, it will look like this, something like that. Not quite, because it turns the bytecode, so it's not Englishly readable, but it looks something like that. So we'll go ahead and we'll do super.get capability, capabilities, and facing. And when we do our actual code, how the code will work out is if capability equals, and I believe it is, it's going to be the capability that deals with energy storage. We'll find it here in a second. Yeah, capability energy. So what we're looking for is capability energy. So it would be this energy, and this, we just have to match the capability. We don't actually have to do anything else with this. So a lot of people will look at this and go, wait, do I have to use Forge's energy storage system to actually use the capability? You don't. The only thing it's going to be looking for is that you are an energy storage. So as long as you return some object to it that is energy storage based, it will work just fine. I actually had a system for this back in like 1.6 that looked identical to the capability system. It's the funniest thing about this is that I was kind of shocked to see the capability system, because I actually do have the system here. We're going to do like a not equal null here, has capability, just so I can then come down here and go if capability equals capability energy dot energy. I don't have to worry about null point exceptions, because if you return a null capability, you can null point. It expects that it does exist. So if we do a simple system here, and of course we have to cast call this. There is a more proper way to do this, but casting is the quickest possible way. Is that it should in theory be an energy capability. So it should actually work. Back to this, we're going to do our power capacity. I know we're doing a lot of this stuff out of order. So we're going to do max transfer. So we do max receive, max extract. We don't need to worry about receiving energy, so we're never going to be able to take energy. So that's going to be 0 by default. So we're going to put 0 there. And the only thing we have to really worry about is then the power transfer. So we're going to call this power transfer, of course. And of course, we're just going to set this to say you can only output 10 power at a time. And what we'll do is we'll try to match our power production. So we're going to do public static int power. We'll call this power creation. We'll say we create 1 power per tick. That way, then you can transfer 10 per tick. So that way, you could use this as somewhat like a battery, which is kind of what I want to use it for if I ever actually use it in the world. So this would be power transfer. And then of course we'll leave it as 0 for the one method. So there we go, we have an energy storage system here. We are going to need to save this, so let's do the save code before we finish any of the logic here. The save code, you literally, this is the way I do it almost every single time. Just come in here, find the read and write MBT, just copy the two methods really quick. You could type them in if you really want to, but you're going to make mistakes because you're new to this. So what you can do really quickly is just copy this really quick, delete what's currently contained inside of it, with the exception of this one, because you want to return super dot write MBT compound. I really like that in newer versions they actually added this return here. Not only does it make it easier to work with tileliness, because you can call tilelinity.write and it'll return the MBT that you passed in right here, but when it does the super.write MBT, it ensures that we can no longer accidentally break this data. This is a very common thing that a lot of people made mistakes in older versions, is that you could accidentally put a ID in here. Say for example, I wanted to make a block that had like 15 subtypes, and I was being really lazy, and I would put an integer in my tile entity, and it was literally called ID. And I was like, oh yeah, we're just going to have a variable in here called ID, and that will ID what type of block we are. So we'll pass that back to our block state system, and then in a block state system we'll just pass that back in and it'll work just fine. But then you went to go save it and you didn't know about what was in here. You didn't know about this write internal thing. And you went to go save an exact string called ID or an exact integer called ID. You would write right over the ID system, then your tile would never load. This is the information required in order to actually load your tile up. So it'll look for this, it'll map this from the class paths. And there's actually a system here, you can actually look through this code here. It's not as easy to understand, but what it does is it goes to the registry, it gets the object, it passes in a class path, which is the string. The string was loaded with the compound ID. And if you had override the ID, it's going to put an integer in here, it's just going to crash the game. So not only did you override the data so your tile wouldn't work, you could crash, well actually you can't crash the game with this, it'll actually throw an error and it'll delete your tile. But that's the ideal at least. So anyways, you overrided these two methods, and once again, override is optional, it's not required. It just reminds you that if say for example the method name of this changed and you went to like the next version, add override would error out and say, hey, you're not actually overriding anything. It's a good methodology. Of course, you also want to do read from MBT compound here, that way you can get any super data, because then you wouldn't read any of this information, which would not only not load your forge capabilities, would then fail everything else. Speaking of which, with a capability system, I believe you could actually just register your capability in here rather than actually overriding these two methods. I'm doing it this way. If you want to do it another way, you can go ahead and do it another way if you figure it out. This is just the simplest way I know how to do it. For the saving, I believe we can just save this to an MBT. It does not look like it has any save code in it. So what we're going to do, just to make our lives that much easier, we're just going to save something really simple. So we're going to go compound, and we're going to do set integer. Make a value called energy, and I'm going to show you the clean way to do this. If you're going to do anything with MBT and you want your code to be incredibly immaculate, you want to not make any mistakes, go to the top of your class file, make some constants, which is what you call public static final, and make something called MBT energy, and you just call this energy. And this will tell you, and it tells you a lot. It tells you that this is an MBT tag and it's for the associated energy, and you put it right here. And that way you don't make mistakes. And then you go and grab your power storage, and we would get energy stored, and we save it. And in your load code, you come down here and you go power storage dot set energy. And is there not really an energy in here? That's the only thing I really don't like about the way that this is designed, is how do I set my energy once it's in here? So I would have to create my energy storage buffer. So what I think we're going to do, and I probably should, well, yeah, we'll do it, there's an easier way to do this. So I'm going to make another class file for this, and we're just going to call this energy buffer something. So yeah, energy buffer. And we're going to extend energy storage. I was going to do like a different way of using an anonymous class, but I just remembered the last video, I believe I told you not to use anonymous classes. So best not to show examples of utilizing something that you shouldn't be utilizing. Actually, let's get rid of all this because it's not too big of a deal to do this. And we're just going to make a really quick method in here, public void set energy. I actually asked King Lemming to add this method into his system, and he told me basically no, and told me it was not a good idea, and that it would expose too much, a little bit of everything to everything. And it really doesn't expose much. So I have a method called set energy, and I would have int energy, and it's really useful. Not only, there's like tons of uses for it, and his own code, so the own code he uses for thermal expansion has that method in there, but for some reason we don't have it in here, so it makes it really hard to say, for example, I wanted to do packet data. I wanted to send my energy to the client. I have no accessor method to set my energy value, and that's a problem. So of course I'm going to make a method here, and that's going to make my life easier. And what I'm going to do is I'm going to change this to energy buffer, and we're going to change this to energy buffer. Of course, we have to put a 0 at the end of this, and we then can just come down to here and do set energy, and we can do compound dot get integer, and this is where we would pass in that key again. This is the reason why I say it's really important to actually do this, is that you can use this. And a lot of times when you're using more complicated MBT data, you'll use this 3 times. You use it 1 to write, 1 to read, and you'll do a check. If you have really complicated data, it's important to do like a really quick if check like here, where it does compound.hasKey, and then you'll check to see if it has a key before you do it. Because we're using an integer that defaults to 0, we can go get integer, and if it's not in there, it will return 0. We can actually look at this code. It'll go has key. If it does not have key, it returns 0 down here, because We don't care if there's a classing exception. We don't care anyways. It's just going to return that we have 0 if it's not there. So this works. So we now have saving and loading. So our energy system works. It's going to return properly. This should never be null because onLoad should always be called. If there is a potential it wouldn't work perfectly, if that ever comes to a case, you just want to move this up to here or something, or put it in your constructor so it's guaranteed to work. Now that we got all that done, we can start working on the actual power creation code because this is all set up. We can now store everything, and we'll probably, I'll do configs at the end. Hopefully I'll remember and not forget. So we got a capable to return. This means wires can connect. I will be unable to show the wires actually working though because I don't have a power mod in my system. Actually, no, wait, I think I do. We could put it next to one of the ICBM launchers and watch the power transfer. That'll work. So we're going to need code to generate. So let's make methods for this because this is the way you're supposed to do it. So public void create power. And then we want to make another method called public void output power because we're going to want to make sure we put this power somewhere other than our machine. And we'll get that in a second. Like the output power, actually, we'll do it right now because it's just simple for me to explain it why I program. We're going to want to get a side. So we're going to do enum facing. And this, yeah, we'll just do facing. And we'll do enum facing, and we want to do values because we want to do all sides. We don't output on all directions, even though theoretically we shouldn't need to output to the top. Yeah, theoretically we shouldn't have to output to the top, but it's easier just to go ahead and loop through these rather than deal with them. And that should do the trick. So we'll do that. And that should work, and we should output all of our stuff. And well, it should loop through the sides. And then we want to get the tile per side, and we need to do this by a block pause. So we're going to do a block pause. Pause equals. I think we can get pause from our block. So yeah, get pause, and we want to add, and we want to do facing dot. I believe there is get index or no get direction back. So that'll give us our block position. We of course want to make sure we do, I believe it is world dot is block loaded. So you always want to make sure the block is loaded first. This prevents orphan chunk loading where the chunk is loaded next to another one and it will immediately deload, which is one of the bigger reasons why a lot of mod packs do lag after a while. So that will do is loaded. Then we want to get the tile entity. So tile entity, tile equals world dot get tile entity. You pass in that block once again. And we want to do if tile dot has capability, and we want to pass in, I believe, facing dot get opposite. So the concept with this one is you're grabbing the block in the direction of the face of your block, but the other block wants to see the direction from its face. Basically, the way to show this off is say this was our block right here, and we were trying to figure out what the block was here. It's going to be expecting to be asked about the other direction it's facing, because it's going to be like, hey, I only provide power from, say, the north side, so I can only power from north out from the face of my block. But then I'm asking, okay, can you receive, that block would be technically to the south of me, so I'm asking, okay, the block to the south of me, can I put power in you? But it wants to ask from the north side of the face. You basically want to make sure that the direction you're asking is the face of the block you're connected to, not the direction you're moving it to. There's also a few other things, so I have to pass in the capability and the facing directions. So in this case, we just want to make sure we do energy capability, or no, capability energy. Yeah, capability energy, not energy. So you want to make sure it has a capability, and then once you ask it has a capability, you then want to get the capability. And this will be high energy storage equals get capability, and you pass in the same exact information. And that should get you the storage information that you need. And you basically, of course, I'm going to put a null point check in here because I don't trust other mods enough to not null check their own code. And that should do the trick. And of course, we forgot a null check right here as well. So you want to make sure you actually have a tile. So tile doesn't equal null. And that should work. So that makes, there's our null check. So we can actually document this. So we get position. Always a good idea to document your code. Because you may come back in here later and be like, what in the world did I just make? And I've done that myself, even though I've been doing this for a very long time. Check the block is loaded. Get the tile. Check tile exists and has power support. And then you just get power. Get power. You don't have to document the null point check in here, and then we just basically go send power. And what we'll do up here is, in order to do our check, we basically have to go power storage dot get energy stored is greater than 0. You don't want to try to run power code if you don't have power to give. And then you just go output power. And that's how that code will get called. And of course you want to document it. Outputs power to all 6 sides. And then you do protected. And of course we have our transfer limit. Luckily our transfer limit's pretty easy. We'll do extract energy and so and so. For the code, the init power equals, I believe we need to do a min max here. We don't have to worry about the match. We can literally just do get extract energy, do integer dot max value and true. We want to simulate it, so we're basically asking, okay, how much energy can you give me? And it basically will give me all the power. And then we literally want to then go to the other storage and go, okay, receive energy, the amount of power you want us to receive. And then we can do false here because we don't actually need to simulate this because we're doing that. And then all we have to do is then go back to our power storage because this will be drained. So this should return the amount of energy that was or has been, if simulated, accepted by the storage. So it returns how much energy it's been consumed. So amount of energy drained. Then we can do power storage dot extract energy, and then we just do drained, and then we do false because it should be true. And then in theory, how this should work is because we set our capacity to 10. This should return a value of 10. Then this should, in theory, consumable. I don't think I've seen a wire that can't consume more than 10 power, and this should basically come back and say, okay, we've done 10 power as well. But there could be a case when we have 1 power stored, maybe 2 power stored, and it's going to do that very well, and it should work. So this is going to be figure out power we can give. This will be give power, and this is going to be drain power. That way it's documented nice and neat, and it's a 3-step process, and that's done. That should do that per side. There are other techniques you can use for this, other algorithms you can actually set up for actually doing power transfer. This is the most common one you'll see. It just tries to give as much power as it can per side until it runs out. The way I normally actually end up doing this, if I'm building more complicated machines and I want to do a much better job at building better behavior for users, is that I would figure out, okay, how many machines do I have around me? How much power can all those machines accept? Then I would go, okay, I want to make sure each machine gets an even amount of power. So if every machine around me can accept 1,000, that means we're doing 6,000 watts. Then I would divide that by 6 and go, okay, I'm going to give each of them 1,000 power. But say I didn't have 1,000 power, say I only had 600 power, then I'm only going to be able to get each of them 100 power, and I'm going to give each 100 power until they run out of power to give. There's also an algorithm to make this work a little better. Say, for example, you didn't know how much power each machine can give in the case of IC2, because it doesn't actually tell you how much power they can receive. You would go, okay, I have 6 sides of the tile, and I have 1,000 watts of power to give. I can then give such and such amount of power per side, but then the first machine only accepts half of what I can give it. You then put that back in your total amount of power, then redivide that by 5 until you go down each machine. And say the 5th machine only accepts half you can give it, then you add the power back that you didn't give to the total, redivide that by 4, and you do this every single time you go to the side. That way you're still trying to give a fair amount to all 6 machines, but at the same time, if a machine doesn't accept full power, you still have power to give, and you're still trying to give that maximum amount of power, but it distributes it fairly, so that way your generator is not outputting maximum power to one side and then failing to feed the other side. I've seen this happen in a lot of mods before, where one side of the machine, I think mechanism is the biggest culprit of it, where one machine will get all the power first, and then the second machine will get nothing, and you'll have problems with your base power not fluctuating properly because of this. To be honest, it's not that big of an issue because of the fact that it is a design challenge. It gives a player a design challenge that they need to maybe think about putting splitters in the network where they make sure that half the power goes left, half the power goes right. It's actually a big advantage to using smaller, lower transfer power cubes to split your power. Say for example you had you could do like 400 watts of power, but then each of your machines can only transfer 100 at a time, and you wanted to split it to a 1-to-3 ratio. You could put 3 of the 100 watt machines on the right and 1 on the left, and then split those back into one wire connection. That way you're then transferring 300 on the right and 1 on the left. It is a design thing. I had to do that in IC2, is the reason why I know that so well. Anyway, so our output power code should work. We'll test that in a second. We then need to do our crate power code. Our crate power code is going to work pretty simply. Do we have snow above us? If we have snow above us, we're good to go. We're not going to check snow often, so we are going to actually probably need to put another check in here, but I'm not going to worry about the check in here. So the check in here actually is going to be like on neighbor change, I believe is what it is. Call when a tile of the side of this block is created or destroyed. There's observe neighbor change and should change. So I think this is what we want. And I'm going to check a tile really quick in ICBM Classic. So ICBM Classic is a tile that I was messing with this other day, and there's multiple methods is the reason why I'm a little concerned if I'm grabbing the right one. So I just updated the radar station. And the radar station does a lot of redstone. And this also, we're going to copy this method as well. So I do want to do a right-click action as well to test that we are producing power. And that'll be probably an easy way. So we'll do the method empty real quick and then we'll edit in real time. And then there should be an on neighbor change block here. So it's get strong power, get weak power, can provide power, can check power, create state. Maybe it's not this one that has a change on it. That's very strange. I don't see it in here. Interesting. Maybe it's the tile ID that does it. Tile power. Notify block of state change. Is that maybe it? Which does on neighbor change, which then does I block state I neighbor change, which then should wrap her back to our system, I believe. Actually, we'll figure it out in a second. So there should be a method in theory that would work. It is when we return false real quick on that. So we'll figure that out at some point, so we're not going to worry about that. But in theory, what you would do is if the snow broke above you or changed, you would want to make sure that inside your tile entity that you did check for it and make sure that was not there was no difference. So we're going to do a boolean, and we're going to do a boolean has snow, and we're going to set that to false, and we're going to then do so on load we want to do a check, and we want to make an integer for this. So normally I wouldn't make another tick element for this, but we're going to do another one because it'll be a little easier. This actually basically means we don't actually need this tick. So what I'm going to do, yeah, I'm going to get rid of it. So we don't need this because we're not going to do any update system, but we're going to do snow check tick, and this is going to be 0, and it's going to build up to a certain number. And what we'll do is we'll knit it at -1, and we'll say okay if snow check timer. And we'll say less than equals 0 because this will be pretty easy. And what we'll do is we'll make another system here, and we'll go okay, how often do you want to check snow? So check snow delay, and we'll say we want to wait every 100 ticks, which is going to be every 5 seconds, which should be okay. This actually leads to an advantage too by doing a snow check this way, is that we could randomize it a little bit, and we could say okay, maybe the tile next to you only updates every other tick, and this offsets the amount of calculations you need to do per tick. So that way, say you loaded your world and all 1,000 of your generators loaded at the same time, you're not doing the calculations for all 1,000 of those generators in the same exact tick. Instead, you could brush them over multiple ticks. So what we'll do is we'll do it here, and we'll do like snow check tick equals check snow delay plus world.random.nextEnd, and we'll say we'll offset it by a factor of 10. So that means you could have some tiles updating like 10 ticks apart from each other. We'd actually even do a 20 on the end of that, but I think it would be a bit much. Minecraft does something similar by checking your block location and then doing that, so that way as the further you get out from a certain distance, the longer it takes to actually do update checks. But that doesn't work in our case because we don't want to be checking every 1,000 ticks or something. We want to make sure we are checking often because snow can move. So we'll do a snow check tick, and then what we'll do here is we'll get the block above us. So we do block pause equals get block pause dot up, and there's a really cool method for that. And we'll then do I block state equals world dot get block state position. So that'll give us our block state, and we'll do if state dot get block equals blocks dot snow, and we will do snow layer. As much as I want to do a snow block, we would then have to transfer that into a snow layer or something. We might do that later. I'll probably do that later, but I won't do that on video. So we got our snow layer. We don't really care how big the snow layer is. We'll do that in a later check. But we'll simply go we have snow is true. If not, we will set to has snow equals false because we don't have snow above us. So then what we need to do down here is we need to go okay, if has snow, we then do power storage dot receive energy and we'll do power creation, and we'll do false because we don't need to simulate this. We don't need to do any checks. We don't need to make sure that it actually did receive power. We simply care that we generate power. So we'll make and actually we want to move this down to create power, and we'll do create power here. So we'll go okay, simply generate power if snow is above, and this is our snow check. Check that we have snow, and then this is our output power. And at this point, this should in theory generate power for us as long as we have snow blocks above the generator. And of course, what we would actually end up doing as well with this is that at some point we would consume it. So every time we did a snow check, we would consume a layer of snow. We could just do this in this here, and we'll do check snow delay every 100, and we'll say like every 100 it consumes a layer of snow. Now we're gonna do a different delay. So we're gonna say consume snow delay. That's what we're gonna call this one. And the reason I want to do this one is because these are two separate tasks. We have our check here to make sure we still have snow, and this is going to mainly be handled by our on neighbor update check, is that'll actually do a lot of the work for us. But we still want to make sure we come through and check it. Ideally, if you really wanted to skirt the edge of your logic, is that you could rely purely on the on neighbor block update check to do all of this for you, and this would cut some decent amount of stuff out of your update logic. But we don't necessarily need to worry about that. You could also do other things if you're worried about lag, is you could do that tick system I was talking about, and then maybe run this logic only every 3 ticks or so, every 20 ticks. Because even though a lot of people think you need to output power every single tick, you can burst power. IC2 is designed around burst power. That's the reason it has that packet system where it goes, okay, I'm going to burst a packet of 20 EU or something. So you can actually do that as well. So we're going to consume a tick delay, and what we're going to do is set this to, I want to say 1 minute. So we know there's 20 seconds or 20 ticks in a second, and then there's 60 seconds in a minute. So there we go, 1 minute. Of course, we can do the math for this if we really wanted to do this as well, but 20 times 60, and we do say that's what that is, but we'll leave it that way. And then you can make constants for this as well. Say you wanted to like output by a certain amount. I'm going to break those apart because those are two separate things. So we'll have a snow consume delay, and we'll put this right down here. So we're going to actually move this, because if we know we don't have any snow, why even bother actually checking? So make another one, consume snow. So you want to go if, and we'll make another counter for this. This will be snow consume tick. And what we'll do is we'll set this to -1. So we'll say, okay, if it's a certain amount, we're good to go. We will save this value though. So just like if you do a furnace, you want to make sure you save your actual timer. So this will be snow consume tick is less than or equal to 0. And we're going to make this random too, because why not? It's a good idea. But this one we're going to randomize probably a bit more. And what we'll do is we'll also put a value here. So we'll go, okay, snow delay, and we'll do random. And I want to random this by 100, so we'll have a 5-second random on it. And this is just simply so we're not doing a ton of block updates at the same exact time. But when we do the configs, this now gives people options. Say maybe they don't want to have a random, maybe they want to have a consistent every single tick consumes the snow. But now we can do a random here. So this will be consume snow delay random. And this will be, we don't want to check snow delay, we want to check yes, we change that to what? Consume? Yeah, consume slow delay. So there we go. That should reset that to, yes, snow consume. There we go. So that should reset our timer. And then what we're going to do is simply do something like this. And we're just going to really just copy this. I'm even going to leave the Boolean checks in there because if we don't have snow, we make sure we turn that to false. So that way when it goes to generate power, oh, actually, no, that wouldn't work. We're going to just ignore that. If it doesn't work, it doesn't work. Somebody gets a free ticket power. So it has a snow layer up there. What we want to do is we want to get the state of the layer. So we want to actually do the... I'm going to actually do this. I'm going to type in the actual class file. Block snow. And there is a property up here called layers, which is going to be between 1 to 8. So we'll be able to get a number here. So this will be an integer. So this will be int layers equals state dot get, and should we just get value? Yes, get value, and this will be block snow layers. So that will give us a layer value. And we want to do is essentially layers minus equals 1. You could also do minus at the end of this, but it just kind of helps readability. We do it this way. And then we're going to go, okay, if layers is less than equal to 0, then we delete the block. So we'll go, okay, world.set block to error, and we'll pass in the position because we just ate the block. Else, we want to update the state. So we want to do it this way. So we'll go state.getWithProperty. Should be get. Oh, I think it's state with property. Yep, state with property. A little confusing for somebody like me. Usually you think you're going to call it get call. So it's a property, then a value. In this case, we're going to pass in the exact property here. And this should automatically give us ability just to pass layers in there. And that should give us our actual property. Of course, we want to make sure we actually store this too. So we're going to have to go state equals that because it's going to change what the value is. And then we're going to do world.set block state. And we want to then go, okay, what is it the method calls on this? That wants a block position and then the block state. So we're going to pass in the position and then the state, and that should update the layer and slowly consume it over time. And that should work. And that should consume everything. Yep, cool. So we make sure we document this too. So reset delay. Get state. We're going to just call this get state because you don't need to do get state and get position. There's some things you want to make sure you do and some things you don't make sure is snow. And what we actually could also even do down here, if this is else, we could just do a return, but that would cancel out the power code here. So there's a few things we actually could end up actually doing. And we could actually move this down to our create power code down here because there's a bit empty. And we could put a return on that so it doesn't produce power. Actually not a horrible idea. Yeah, let's go ahead and do that. Because we don't need to put this up here. So it generates power, and we go down here. So this will be actually output power. Output power. And then we simply put down here as if it's not actually snow. Go else. And then we just do a return. So we go, okay, don't output power. And of course there's better ways to do this. Like we could put a boolean here and then simply go like if no snow or something. Or probably not the best way to do it, but it's an option. So this will eat our error. So we update layers. So update layers, update block state, kill block. And of course put some spaces here, and it's nice and readable, and then that basically done, and we can document this as well. Creates power and does consume snow check. So that's everything for this, and this should be a functional machine now. The only thing we're missing is doing water. Now, even though I said that it's part of the design was going to be, I'm going to probably do another video for fluid tanks later because there's another process involved in that, and I believe I need to do, I don't know, is there actually like a fluid? Private fluid tank? There's a fluid tank, so we actually could do this. But we'll do that in the next video, so I'll just put it there as a reminder to myself that it needs to be done in order so I don't forget. We'll go ahead and test this now. So let's go ahead and stop the game and run it again. The reason why we can't just open the game up and let it run is that IntelliJ can reload code for you, but it has a limit on what it can do without additional tools provided. Your limit on what code you can reload is if it's inside of a method and it's not too complicated, it'll reload. If you did anything outside of the method, like do what we just did right here, you will not reload because it effectively has to reload the entire class. Right now, I think it's limited to like method reloads. It was almost done. Another 40-minute video. It did say this would be longer, and we haven't even finished all the logic. Like there's a lot more we could do with this. Like we could do particle effects, we could do some packet data, we could do some power fluctuation. There's a lot you can do with a simple block, and this is the reason why I did start the single blocks mod series, is that people think you need a very large mod to make wonderful content. You really don't. You can take a single block and a single item and you can do wonderful things with them. You can do massive amounts of changes and everything else. You take something like the wooden bucket. Most people look at the wooden bucket, it's like, oh yeah, you made a vanilla bucket that happens to have a wood texture. That's actually not what that mod is. That mod, I mean, texturally it does look at a wooden bucket, but you have more functionality. You can pick up every fluid with it. It's in a single item. You can then cause fire damage by picking up lava. You can have it leak. You can have molten fluid drop out and catch the area on fire. So there's a lot of detail in that mod that most people overlook. That's probably why it never gets downloads. But with a single block mod series, you can take single blocks and do wonderful things with them, or items, because I'm not making a series called single items either. So just keep it one series to make life simple. So go ahead and test this now that the world's loaded. Or, well, almost loaded. So we're going to want to kill like all of these off but one, so that way we can do debug testing and make sure the code is actually running. So we have one block, and it does things, and we just need snow. Do it this way. So we want snow layers, not the snow block. Even though they're identical, they're actually two different blocks. You see one's called a building material layer with decoration. I don't know why they separated them. They probably could have got away with one block for all this. So we got snow up there. We're not going to be able to do anything. So we can't really right click this. So what I'm going to do is we're going to add a right click method. So let's go ahead, close IC Beam here so I can actually find things. Output a message. So first thing first, we make sure we're only running stuff on one side. In this case, we want to do world.isRemote. This is basically saying, isRemote is saying, am I on a server right now? But on the client. So if isRemote returns true, you're on a client. If it returns false, you're on a server. So what we're going to do is put a not check in front of this. So effectively, it's going to invert it. So then what it's going to turn is going to return true if we are on a server. So we want to make sure we run our code only on the server, and which means we also want to make sure we return true down here, because if you return false on the client and on a right click, it will not transfer that right click call to the server. And of course, we're going to return true on both sides, so it doesn't matter. And in this case, we really just want to do player.at, I believe, actually, to send message, they changed the thing. And we want to do a new chat component or text component. Normally, you would do a text component translate, and you would then provide all your information. But we're going to do a string just because this is debug information, is what we're going to work with. And we're just simply going to go power, and then we're going to do plus. We need to get the tile state real quick, so let's do this real quick. Tile entity, tile equals world. Get tile entity position, and then we want to go if tile is an instance of. You want to make sure you do an instance of check. You don't want to just do a null check and then cast. You want to make sure that the tile that is there is your tile, because there is a chance that it could break and it would not be your tile. And then what we just want to do here is just get the power storage, and we're gonna have to expose that publicly. We'll have to reload for this, because I did not actually give myself a way to do this. So we need to make this public. We probably should make our fluid take public too, so we can actually access this later if we do another video for this. But I'll probably do another video on that another day. So this will, of course, we can then do power storage dot get energy stored, and that'll of course output our power. But we have to reload the game because this will not actually reload. I will show you how that actually works. So if I hit reload, which I have a hotkey for it called which is Alt R. That's not a default hotkey, but if you do reload, which you normally would do would be build should be a button up here. But you saw the text down there said you couldn't reload in it. You should restart your instance. Is because we changed variables. What IntelliJ can change is limited because of the way code compiles. There are plugins you can install that do remove that limit, but keep in mind that even though that limit can be removed, your code can get funky. Like, it can actually start to act up. There's a reason why IntelliJ doesn't support it. Eclipse did the same thing, although I think they natively support it now. I call this debug mode is what I call reloading, but actually the terminology for it is like runtime reload or something. And I'll show you what debug mode is here actually in a second, so that way you know what the actual word for debug mode is. Debug mode is effectively we've launched in it. Instead of hitting run client, we ran in debug mode. What debug mode effectively allows you to do is that if you put a break line here, as soon as this code goes to run, it will stop and pause there and let me sit there and toy with the code and look at it and see what it's doing. As a developer, it's the most important thing you probably should learn how to do, because a lot of tutorials will tell you, okay, put print lines here, put extra information here that will display for you to do things. That is actually really useful to learn, but debug mode is the winner. It's what actually will save you days, not just hours, days of time. Okay, so get in here, pop back in, and I'll show you that right click method, and of course debug mode with it. So we right click, of course you saw the game pause, and then it will pause here. And what debug information gives me is I have access to all the information here. I can see what my world is. I can see everything that's in the world at any given time. I can see what my position is. I can see what the block state is. It'll tell me it's a block snow generator. I don't have any property data or anything attached to it. It'll tell me what hand I right-clicked. I right-clicked with my main hand. It'll tell me the face of the block, which is south. So it gives you a lot of information. You can sit here and fine-tune dig through this. I can see exactly what's in the player's inventory, what language he's currently in, everything. I have that information available to me at that time. And then the coolest thing ever is I can now step through the code. I can walk through it. So we just ran over that line. It goes, hey, I just got the tile entity. I now have access to the tile entity. I can see what's in the tile entity. So we can open this up, and it's collecting the data currently. It's a little slow. So it hasn't run its snow tick. It hasn't run a consume tick yet. Power storage is there. Fluid tank is null. Has snow, false. I can see the world. I can see the position. I can see all this cool information here, and everything is there. So we can continue stepping through this and go, hey, it's an instance of that, and then it'll output the tag to me, and then we'll hit true and return. Cool thing with this is you can also step through Minecraft code. So if I hit next on this again, assuming it doesn't like bug out, I can then look through Minecraft code. I can see exactly how all the Minecraft code works. I can look at all of its information as well. But we'll go ahead and remove this. Although there's another cool thing we do with this. If you right click on this, you can set up conditions for this. So say for example I wanted to go, okay, if pause dot get z equals 0. If I wanted to only that break line to run on that position, I could, and it would actually run with that. But of course I don't actually care if that was the position. I can hit play and it'll run again, and I can get back in the game. And of course it'll tell me that power is 0 because I don't think our code is actually running. So go ahead and look at this. No, it is running. So we can see we're on tick 101. So you're going to get 20 of these ticks a second, give or take, depending on if your CPU stalls out. And it goes, okay, we have snow, so we're creating power. And we're going to dump into here. And we should receive power. So power creation, power storage, receive. We're going to go into this check just really quickly to make sure it actually functions. So we're going to go can receive. That should return proper. No, actually that's going to return can receive as false. Can receive is if max receive is greater than 0. So maybe we tripped up on our max receive. We actually did. We inverted our max receive and our max transfer. So we got to fix it up here. Yep, so we inverted these. So what I'm going to do really quickly is just grab this and pop that right there. We won't have to restart to fix this, but we will have to break the tile. So we'll go ahead and hit play, which will come back down in the next update tick. So we'll go ahead and break that and put that back down and put this back here. So we're still not getting power. So what we want to do is hit the break line here again, and we can sit here and we can walk our way through it. So we haven't got the has snow yet. So we have to wait another check for this. So eventually we'll get down to a point here. We can put a breakdown line here, and then what we do is we just wait, and Minecraft will sit here and run in the background. And eventually at some point, the has snow delay will work. And you know, actually it will not. You know the reason why it won't? It's because snow check tick is not being reduced. So we have to do something like this. This is the reason why debug mode is important. And then we also need to do snow consume tick minus equals 1. So make sure we have that. And let's actually put this one down here and make sure we do that. And actually, really cool trick you can do is something like that. And this will actually save you a little bit of text space. It's a bit of Santic sugar that's magic. But you saw how you can do it both methods now. So I'm going to go ahead and reload this. We can actively reload this. And what you'll do is if it actively reloads, you'll see a green text box in the bottom that says, cool, you're good to go. And then what we can do is hit play. And of course it'll run. So it finally actually got snow tick down to 0. And it's going to set the delay to a new value. And we'll see that go to 105. It'll then grab the up position. It'll then find it. And by the way, delay you're seeing with it is just IntelliJ taking a moment or second to run, especially with something like OBS running in the background and everything else I'm using for recording. It does take a bit of time. So to get your snow layer, and yeah, it says, okay, you have a Minecraft snow with layers 1. So we have 1 layer of snow right above us. And it's going to go, yeah, you have snow and you're good to go. And now that we have snow, we can jump down here and remove the debug line before I forget it. And it just skipped right over that for whatever reason. But we'll go ahead and hit play. And I'm going to hit reload one more time just to make sure there wasn't a formatting error. And what we should see is that there should be power at some point. So let's go ahead and put this here. And we should see that tick to true. And we'll go ahead and do this. And what we can also do with this really quickly is, in order to reduce our code, is we can actually do has snow equals that. And that will cut some more code out of our bulk. So we do reset tick, get block, do check. And it just put that in the wrong spot. So we finally did actually get to that point where it actually did create power. And let me quickly finish this, do check. reload really quickly, that way the formatter runs. And what we're going to do is we're going to go ahead and hit step into on that line. And we're going to hit back out. So what it'll do when it does a step in, step out, it's going to step into all of your method calls first, which is going to be to get energy storage and everything else. And then you just have to let it run. I'm going to actually let it reload and run again because it'll just run the next tick anyways. And we'll go ahead and put a break line there. So I should get a power run call here at some point. Oh, in theory, we should get one. Oh, you know, one thing I did forget to do with this. If world.isRemote. See, we're running code on the client and server. You really shouldn't do that. You should only run it on one side. The client should basically just be a render dummy. Server should be all your logic. So we'll let that run, and that should give us an indication what's going on. We're on check 22, and currently it does not think we have snow. So I'm going to go ahead and make sure we put a line there so we can see what it's doing. And we actually don't have snow on top of this. So that's going to run, and it's going to be like, hey, yeah, we don't want snow, dude. Let me quickly... Okay. There's no such word as quick when it comes to the fact that we're doing that. Okay, so cool. That's going to run. Our power check is now in good hands. So this is now going to do its snow check tick. It's only going to do that every tick as long as we have snow. So that delay is going to be actually reduced. So it's going to then output power. And that should work. Put that off here, hit play. And what we should be able to do now is right click, and we have 50 power. And of course the snow block got consumed, so we just saw the consume check work, so cool. That's all in there. And what we can do is of course pile the snow up. And this should slowly but surely generate power, and we can sit here and watch it until it consumes the snow and it'll run out of snow. And then in theory what you would also do is you would put this next to something that would actually consume the power, like say like a screen. Oh, I need to fix the pig block on that. But we would go in here, and then of course we can see this slowly but surely get power fed. It doesn't look like it's actually receiving power, so what I'm going to say, let's put more snow up here. Not too much because I think it'll turn into a full block of video. So we know that is producing power. Now we need to check our power output code. So go here, get the tile, is block loaded, cool. Get our tile entity, has capability. It does not seem to be has capabilities working. So either I messed up on the way I coded my tile over there, which is a really high possibility. We're gonna find out in a second. Oh wait. Why are you back down there again? Okay, because of course the tile is going to be not null. We can fix this. If you ever have to debug this and you need to be able to debug on a specific line, just make 2 if statements. It's called nesting your if statements. It's not clean, but it works because the compiler is just not going to care. If somebody ever complains about your code being ugly, just remind them the compiler gives no shits. So this will debug on that line here in a second as soon as we hit play again. Hit play, and that should give us, yeah, exactly what we want, which the tile we are connected to is launch screen. And we can go in here, and of course that's going to do get opposite real quick. And that should have returned true. So that's capability. Yep, cool, we're good. Come back down. So sweet, we actually have this, and we of course can put a break line here so we can check it next. So it's going to go get my energy storage, which is going to return power buffer from the tile powered machine. This is not the same power buffer we just made. This is a different tile altogether. Speaking of which, I made energy buffer over here, so it doesn't matter either way. The only difference between that one is that just gets the max storage. So of course it's going to return true, and we're going to figure out how much power can we extract. Because we have an extraction rate. So, you know, I never really did like how this was set up. So, how the thermal expansion machines are, they're set up they can transfer power, but I really don't want to expose these tiles to being able to receive power from an external source. So you don't want to, like, return actually has a capability, but you also wanted to kind of have one so you could extract energy. Actually, to be honest, we probably didn't even need to implement capabilities on this to work. We're going to have to break this, though, in a second. So what we could actually do is return has capability false, and it should work just fine. Remove this, and we're going to have to tab back into Minecraft to see if it gives me back control. Break our block. Put it back down. Feed it more snow. We have to give it a second until it does its update check. There it goes, consume snow. And it's putting all the power in here. So I'm like, oh wait, we have no power transfer. I'm like, oh wait, there it is. So yeah, it's working. So it's outputting power. And in theory, what you could also do is pump power in this. So actually, with that being designed the way it is in theory, this will transfer power to its neighbor. And then transfer power on there. So that's actually a cool feature we just accidentally made. Although this is also going to transfer power to all its neighbors, so you're going to have a reciprocal power transfer issue. I think if you really wanted to make this a legitimate feature, you're going to have to code a little bit of logic to go, okay, to the north is where the tile is. So like say for example we had a line of these. What you don't want to have happen is the power transfer from this machine all the way down that way. Instead what you want to do is go, okay, I know there's a machine that can receive power over here, and what you would do is you would go, okay, my power index is 0, 1, 2, 3, 4, 5, 6, 7, and you would simply say, okay, transfer to the one with the lowest index. That way it makes its way towards a machine with power. And of course then you would do some split code to say if you had like machines off to the left and right, that way you actually would end up with stuff. And let me grab that, just an example. So that way power would actually make its way all the way over here. And of course feed the snow. And what we're actually going to do with this really quickly, okay, I think snow is a craftable item, so we'll do with the on right click method, and let me find it again, is we'll actually add a system here that goes if player.get held item hand dot is empty. So we're actually going to go if it's not empty. So if you don't have anything in your, if you have something in your hand, we're going to return false. If you do have your hand empty, it'll return true and you'll be fine. So that should work. And what that'll do is that'll allow me to do this, so I don't have to worry about it accidentally doing the block check. And this is actually a little bit quick on the power code. I don't know if we actually could make it snow here locally just to test this, but in theory this would slowly consume snow. Actually the fast rate makes sense because then it would make it balance better. But in theory, you're going to get a lot of power down at this tile, and it works. You could actually power your IC beam launchers with this, which would work really well. But that's the end of this video. I might come back here after this with fluid tutorial just to do that, but that might be tomorrow rather than today, because after all, we've already done 3 videos and I still have to do a lot of work. So I'll see you guys later.